Hello and welcome back to a video series on MAC 1105, College Algebra. My name's Sean Perry. These are guided notes number 11 in the series on section 3.3, linear functions. One of the main properties of lines that we want to remind ourselves of is slope. Any two distinct points on the plane determine a line that passes through them. And we might ask questions about the steepness of this line. How much we went in the horizontal direction versus how much we've gone vertically is what we mean by steepness. To do this, I want to identify between the 2 points how far to the right we've gone. And then I want to determine how much up or down that we went. But these two values are given by the differences between the coordinates. And so what we're going to do is define the slope as the ratio of these two things. Now, it doesn't matter which one is our first point and which is our second point, as long as we are consistent with our notation. You could reverse the order of subtraction on the bottom and on the top, and you would still get the same as long as you reversed both of them. Let's see what that means over here for this collection of points that we're asked to evaluate. Because the order doesn't matter, I'm free to call this the first point and this the second point. Now, the difference of these two y values is going to give me 0, and the difference of the two x values isn't very important, because we're just going to get 0 here. This is passing through the points -3, -5, and 4, -5. And a quick graph reveals that that's a horizontal line. Anything that has a 0 slope is going to be a horizontal line. On the other hand, here we have two more generic points. Let's again call this x1, y1 and x2, y2, and plug them on into the slope formula. This will give me -2, -5 over -4, -3. That's a -7 on the bottom and a -7 on the top. So we wind up with a slope of +1. Positive slope indicates that it is increasing. And if we were to find a negative slope, it would be a decreasing function. For the next 2 points, we can see that there's going to be a bit of a problem. If I plug them into the slope formula, what I wind up with is division by 0. Division by 0 is not a defined set of operations that we can do in mathematics. Notice that we also have a vertical line which would pass through these 2 points. So we should keep in mind that undefined slopes imply that we are looking at vertical lines. So to recap, if we have a 0 slope, it's a horizontal line. If we have a positive slope, it is an increasing line as we go to the right. If we have a negative slope, it would be a decreasing line as we go to the right. And if we have an undefined slope because of a division by 0, this is going to pertain to a vertical line. Next, we're going to want to learn how to get the equations for lines that pass through any points or that we are given a slope and a point for. The way that we can remember this is just by looking at the slope formula again. One should never memorize more than one has to in a mathematics class. And this formula actually gives us point-slope form. If I just multiply on both sides by the x terms, what I'm going to wind up with, switching both sides, is y2 minus y1 is equal to m times x2 minus x1. Now, this is true for any points, x2 and y2, and so we could consider that to actually be the variable of our expression. And lo and behold, if I do that, I get an equation for a line, one that has the variables y and x, and one that has a point, x1, y1, and the parameter for slope. So this gives us something we can plug information, such as in 5 and 6, into and manipulate it in order to get it into slope-intercept form. Let's see how that would work. My x1, y1 is given here, and my m is given here. Plugging all that in, we have y minus 6 is equal to -2 times x minus -4. That's +4. Now, distributing the -2 and adding 6 to both sides, we have our equation in slope-intercept form. Let's continue to practice this. If I have a slope of 5/8, an x1 of 15, and a y1 of -9, then my point-slope form would look like y plus 9 is equal to 5/8 times x minus 15. This is going to give me y plus 9 is equal to 5/8 x minus 75/8 when I distribute, and minusing 9 in terms of eighths is going to be the same thing as if I had subtracted 72 from this, which will give me 147 over 8. As such, 147/8 is not going to be simplifiable, so this is how I would leave things. For the next two, we're not given a slope. We have to calculate one first. So let's do just that. This would be my x1, y1. This would be my x2, y2. And what is my slope? That will be minus 7 minus 5 over 14 minus 16, which gives me minus 12 over 2 negative, which is positive 6. We can pick either equation that we want to plug this into. Let's take y minus 5 is equal to 6 times x minus 16. Distributing my 6, I get 6x minus 60 plus 36 is 96. And we want to add 5 to that to bring that over from the other side. And this gives me y equals 6x minus 91. For this one, if I do my slope formula, I'll have minus 3 minus minus 5 over 5 minus minus 2. Negative 3 plus 5 is 2, and 5 plus 2 is 7. Plugging this into our point slope formula, we could plug in minus 5 here to give me a plus 5, and 2/7 for my slope, times x minus minus 2 is plus 2. This gives me y plus 5 is equal to 2/7 times x plus 4/7. In terms of sevenths, 5 is 35/7. And so subtracting that from this side, I'll get y equals 2/7 x minus 31/7, which you can see here, as this is just 5. And so this is our answer. This next one is quite similar. They've just kind of hidden one of the points for us. They say that it has an x-intercept of x equals 3. But of course, the y value at an x-intercept is 0, and that's our second point. We then calculate a slope, 11 minus 0, over minus 1 minus 3. And this gives me negative 11 over minus 4, which is just 11/4. So now I have y minus, take any one that you want. How about that 0? It's the easiest one. Is going to be equal to m, which is 11 over 4, times x minus 3. And distributing, we wind up with 11 over 4x minus 33 over 4, as such. Now, moving on, identify the slope, y-intercept, x-intercept of this line described by this function, okay? Also graph the function. This is no big deal. All we want to do is identify the slope and y-intercept, since this is given in a kind of y equals mx plus b kind of form. The y-intercept is 2, meaning that when my x value is 0, my y value is just 2. So we plot that point. And then the slope, which is 4 over 1, tells me that when I go to the right by 1, I'm going to go up by 4. So if I go to the right 1 from this point, I have to go up by 4, and this gives me a second point. Once we have a second point, our line is 100% determined. Only one line will pass through those 2 points, and that's our graph. What else did they want? They wanted the slope. Okay, that's done. The y-intercept, that was pretty much given. The x-intercept, well, we can kind of see that it looks like a certain fraction here. It's halfway between 0 and negative 1. Let's find out what it is explicitly. So that will be where our y value is equal to 0, or our g of x value, if you like. So when is g of x equal to 0? For what value of x? To do this, we need to take the rules for g of x and solve them for x. Minusing 2, dividing by 4, I solve for my x, and this is just negative 1/2 once we simplify. So my x-intercept, the x value when y is 0, is given by minus 1/2, and that accords with what we see on the graph. Find the slope, x-intercept, and y-intercept of the graph of the line, rewrite the equation using function notation, and graph the linear function. All right, this is no big deal. The first thing that we should do, though, is we should rewrite this or this, doesn't matter. This is in standard form, but this is what they gave us. Rewrite either of these to solve for y, and you'll get the same line. So how do we do that? Well, first we want to minus the 12x over to the other side and get 4y equal to minus 12x plus 8. Then we want to divide by minus 4. Dividing by negative 4 on both sides, this is going to give us 3x minus 2. This gives us a slope of 3. It gives us a y-intercept of minus 2. Notice that we could have gotten that straight away from the original equation by plugging in 0 for my x value and dividing by 4 to give me minus 2. Likewise, the x-intercept could be found from the original equation or from the standard form equation if you plug in 0 for y and divide by 12. or here, dividing -8 by -12. Either way, if my y value is 0, I have minus 12, x is equal to -8, and dividing by -12 and simplifying, I have 2/3. So our x-intercept will be at 2/3. And we could also do that from the equation of y that we got here. If I set y equal to 0, and then solve this equation for x, we get 2, and dividing by 3, we get 2/3. If I choose h to be my function, and we rewrite this in function notation, that's just replacing y with h of x. And that gives us h is equal to 3x minus 2. What does the graph look like? Well, it's going to have a y-intercept at -2, and a slope of 3, meaning we go over 1 and up 3, over 1, up 3, over 1, up 3, and so on. So this is my line. As such, here they want us to write the point-slope form of the equation that satisfies these conditions, but all they've done is give us xy pairs with a different name. Notice that all we have to do here is recognize that this is my x and this is my y, my x1, y1, if you will. This could be x2, y2, and we could proceed as we have before. What is my slope? Well, it's going to be -12 minus -2, divided by -4 minus +2. So we take our difference of y values, and we're going to get -10. We take our difference of x values, and we're going to get -6. This means that my slope is 5/3. To write this equation in point-slope form, we just need to pick one of these pairs and write y minus -2, for example, is equal to 5/3 times x minus 2. And then to solve this and put this in slope-intercept form, I need to distribute the 5/3 and bring that other +2 over to the other side. So this would give me 5/3 x minus 10/3. And now we want to put -2 in terms of thirds. That's -6/3. So what is my slope-intercept form? It's going to be 5/3 x minus 16/3. This one here has the same procedure, except perhaps we might be thrown for a loop by noticing that our slope is 0. The 0 in the numerator causes no problems, and so what we'll wind up with, if I plug this into point-slope form, is y minus -20, or +20, is equal to 0x. Well, what's my x value going to be here? -2 in parentheses. And so this 0 on the outside kills this entire right-hand side. And if I just rewrite things a little bit, this will give me y equals -20, which is the constant value that we observe y being. So notice that this is slope-intercept form, right? Even though it is missing an x term because my m being 0 made this whole term go to 0. Here we're asked to identify the slope, y-intercept, and x-intercept of this line and to graph it. It's the constant value of 7. This is very similar to the last example. What we have is a constant f of x value. No matter what you plug into x, there's nothing to do. You just get 7 back. And so when you plug in 5, you get 7. When you plug in -5, you get 7. When you plug in 0, you get 7. This has a slope of 0 and a y-intercept of 7. And as such, we just wind up with this flat line here. So what's its y-intercept? Well, it's 7. What's its slope? It's 0. What's its x-intercept? It doesn't have one. It doesn't have one, and lines need not. If they are constant flat lines, unless they're the whole x-axis, they might never hit the x-axis. And as such, this one does not have an x-intercept. This one's a bit different because it is not in slope-intercept form, and neither can it be put in slope-intercept form, because it defines the constant region where x is always -5. That's this collection of points here. Its slope is undefined because it is a vertical line. Its y-intercept does not exist because vertical lines need not hit the y-axis. Its x-intercept is also -5 because its x value is constantly -5. Here we're asked to give the equations for each one of these lines. This is going to require us to find the slope and their y-intercept, unless they are vertical, in which it'll be x equals a constant. The y-intercept of this one is 3. So we have y equals something x plus 3. What is the slope? Well, it goes over to the right by 3 units and up by 2 units. So I put the 3 on the bottom, the 2 up top. That's my line. Here we have a vertical line. They have the form of x equals a constant, and that constant here is 1. All the x values are given as 1, and the x values being constantly 1 defines this line. Here we have another one. My y-intercept is given as 4, and our slope is going to be, well, let's see, how far do I have to go over before I get to another constant value? Looks like I only have to go over 2 and up 1 before I get to the next clean point. Here we have a flat line, which has the form y equals some constant. Because the slope is 0, it eats the x term. And what is that constant? It's just 3. Y is constantly 3, and that defines this horizontal line. Now, this actually is in standard form because the leading coefficient is positive, everyone's an integer, everyone's happy. Okay, what do they want us to do with it? Identify the slope, the y-intercept, and the x-intercept. Okay, so I'll just throw out there, if you have an equation ax plus by equals c, then moving the ax term over and dividing both sides by b, keeping in mind your a is going to be negative now, will give us slope-intercept form. So we can actually look exactly at these a's and b's and figure out what our slope is going to be. But if that's a little too much to remember, just remember that you're solving this equation for y, right? If I minus 18x to the other side and divide both sides by minus 6, remembering to distribute the minus 6 into each term, we wind up with 3x minus 2. The slope is 3, the y-intercept is minus 2, and the x-intercept, well, at what value will y be 0? If x is 0, y is minus 2. But if y is 0, what value does x have? Adding the 2 over and dividing by 3, we would get x is equal to 2/3, which tells us the x-intercept. It's easy to graph the equation. Once it's in slope-intercept form, we just start at minus 2 and go over 1 up 3 to give it a slope of 3. Notice that it'll continue to go over 1 to the right and up 3, and if I go back by 1, it needs to go down 3. It still has a positive slope because we're going to the left in this case. Connecting my dots, I get the following line. Voila. Now we're going to talk a little bit about perpendicularity. So to be perpendicular means that it is at a right angle to something. They are as opposed as two lines could get. And the idea behind perpendicularity is that there is a relationship between those two slopes. If two lines are parallel to each other, which we sometimes write like this, with two parallel lines. Looks like an 11, but this is the symbol for parallel. If we have two parallel lines, well, then they have the same slope. But if they are perpendicular, they have a different relationship. They have a negative reciprocal slope from one another. This upside down T symbol means perpendicular. So the slope perpendicular is the negative reciprocal, or 1 over and change the sign, from the original slope. So we have two pieces of information given from this graph. One is that the dotted line goes through this point, which is minus 4, 4, and that it is perpendicular to this graph of the solid line, which has a slope of 5. This means that the perpendicular slope is going to be its negative reciprocal. And plugging that in, we wind up with negative 1/5. This gives me everything I need to put it into point slope form. This would be y minus 4 is equal to negative 1/5 times x plus 4. Now, that being said, to get it into slope intercept form, we would distribute the 1/5 and bring my 4 over to the other side. So negative 1/5 times x, negative 1/5 times 4, and we're going to want to add 4 to this equation. But remember, we need to get like bases, so this is actually 20/5. 20/5 minus 4/5 is positive 16/5. So we wind up with y equals negative 1/5 x plus 16/5 for our slope-intercept form. Now, to write this in function notation, we're just replacing the dependent variable with g of x and saying that that is negative 1/5 x plus 16/5. There's very little to do to translate this from dependent variable notation to function notation. Here we have a set of parallel lines. It says the solid line is minus 5x minus 6. That means its slope is going to be equal to minus 5. And that'll be precisely the same slope for any line parallel to that. Here we have a parallel line to that, which seems to pass through the point minus 4, minus 1. So to put this in point slope form, I would have y plus 1 is equal to negative 5 times x plus 4. If I distribute my minus 5, I get a minus 20 here, and minusing another 1 from that, we get minus 21. So this would be y equals negative 5x minus 21. As such, in function notation, this would be g of x is equal to minus 5x minus 21, and we leave it at that. It says Find the equation of the line that is parallel to this line and also passes through the point 5 minus 5. Well, let's get this in slope-intercept form so we can see what its slope is, right? If I leave the minus 4y right where it is, but I bring everything else to the other side, I get 5x minus 40 over there. And dividing by minus 4 against both terms, I get minus 5/4 x plus 10. So we see that this thing has a slope of minus 5/4. To find the line that's parallel to it passing through minus 5, we could use point slope form. This would be y plus 5 is equal to minus 5/4 times x minus 5. They say they want this in general form, and that's fine. Here's how we could do that. We could multiply both sides by 4, distributing would give me the following. Let's distribute that negative 5 in, and let's bring our other terms back over to the left-hand side. This would give us 5x plus 4y minus 5 is equal to 0. Now, to address the perpendicular situation, in point slope form, we would have y plus 6 is equal to, now we want the negative reciprocal slope, which is going to be positive 4/5 times x plus 3. To get this into general form, let's multiply on both sides by 5 first. That'll clear my fractions and make this slightly easier to work with. Distributing by 4, I get 4x plus 12. And bringing that 4 over to the other side, we have minus 4x plus 5y. Bringing my 12 against my 30, I have positive 18. Now they want us to sketch all 3 of these lines on here. Okay, I put this first one in slope-intercept form, so let's take advantage of that. I'll plot the first one in blue. It's at 10 with a slope of minus 5/4. So there's its y-intercept. If I go over by 4 units, I need to go down by 5 units. And there's another point. Over by 4 units, down by 5 units. There's another point. So let's connect these points. Now let's graph. We know that this next line goes through 5 minus 5, which is here. And we know that it has the same slope as this guy, which means going over 4, down 5. Or if I wanted to go left by 4, up by 5. Left by 4, up by 5. Left by 4, up by 5. So here's my next line as such. Finally, let's graph the perpendicular one. We know it's perpendicular and goes through minus 3, minus 6. Minus 3, minus 6 is right here. And it's perpendicular, meaning this one has a negative 5/4 slope. So we're going to put positive 4/5 for our slope. So that means going over 5 units, 1, 2, 3, 4, 5, and up 4 units, 1, 2, 3, 4. Here we are, over 5, up 4, and so on. I think that's probably enough points that we can get a good picture of what's going on and confirm that it looks pretty perpendicular to me. That looks very right-angly, except for the wiggliness of my bad handwriting. Okay, so let's move on to the next ones. These ones are a good deal briefer because they just ask us to decide whether or not these lines are parallel, perpendicular, or neither. To find the slope, we need to plug this into point slope form with an x1, y1, and an x2, y2. So that's going to be minus 23 over 1 minus minus 14 is 1 plus 14. This is 15 on the bottom and minus 15 on top, which gives me a slope of minus 1. For the next one, we have a slope of minus 9 minus minus 57 over 3 minus 15. This becomes 48, and this a minus 12, which gives me a slope of minus 4. That means that they are neither parallel nor perpendicular to each other. A line parallel to this one would be at minus 1, and a line perpendicular would be 1 over minus 1, would be minus 1 over minus 1, which is positive 1. A line parallel to this one would be at minus 4, and a line perpendicular to this one would be at negative 1 over minus 4, which is positive 1/4. Let's just do that again. With our x1, y1, x2, y2 formula, we wind up with a slope of minus 8 plus 12 over 10 minus 14, which gives us 4 over minus 4, or rather negative 1. For our second slope, we have 15 minus 1 over negative 7 minus 7. This gives me 14 over minus 14, which is minus 1. They match, and they are therefore parallel. All right, that's going to do it for this video. Thank you very much for your patience, and have a great day. Good luck with your studies. I'll see you in the next one.